Thanks everyone for joining our talk. I'm Niranjan. I'm responsible for taking care of the advanced threat hunting program at Cyberproof. This is Archana. So, a twist in the story. We'll be speaking on a different topic. It's not the one that was just announced, just setting up the expectation right. So, we'll be talking on different attack investigations that we have been performing across our telemetry and our customer base, learning through where the EDRs have failed multiple times. And this purely on the info stealer side of the payload that we have analyzed. So predominantly, there was one particular loader by the name IDAT loader. It was also called as hijack loader by some of the competitors. I will be talking only about IDAT loader campaigns that we saw active for close to about 18 to 24 months, starting early 2023 to end of 2024. So short introduction of myself. I have been into the cybersecurity industry for close to about 18 years. I have worked with Microsoft, SentinelOne, Symantec, McAfee, predominantly into malware analysis, reverse engineering, threat intelligence, and threat hunting. I also partner along with the MDR and the DFO team very closely. That's how I learned about the threat landscape, EDR detection gaps, and then supported their investigation throughout my career.
Hello everyone. So myself Archana, I'm senior threat hunter working along with Niranjan. So I have 10 plus years of experience across all cybersecurity domains. Like I worked in vulnerability management, incident response, SOC, threat hunting, and as well I worked in SentinelOne, Microsoft previously. So we will be going through the IDAT loader and as well as how we info stealers have predominantly evolved using it.
Okay. So we actually take part in this monthly webinars happening at Cyberproof. It just happened yesterday. It's a recorded session. If you guys are interested to know about what did we investigate throughout that particular month, you can always join this session. Yesterday's one is recorded, by the way. All right. Today's agenda is more about looking through the lens of a SOC analyst and triaging different incidents related to IDAT campaigns. We did find kind of two waves of IDAT. So we just named it as variant 1 and variant 2. We studied the code level of these loaders. So we'll show you how the code blocks of variant 1 and variant 2 looked similar. We'll talk about the different apps different campaigns that used legitimate apps names at the delivery stage, and then how did they constantly change the benign process into which they were performing process injection. And that's just to evade your detection logics. Then the entire research is primarily based on samples collected from VirusTotal and through the knowledge that we gained through different incidents that we worked in different companies. Just a disclaimer.
So now we will see the high-level overview, like how we track the IDAT loader technique, as well how info stealers, they evolved over time. So back in August 2023, we had a case with respect to Luma stealer. So this one, we saw the new technique named IDAT loader. So IDAT loader, what they were doing, they were hiding the payload in the PNG file. So inside the PNG, you can see a file, like an image, but inside that there was a payload. And purely the decryption, decompression, execution, everything happened in the memory and not in the disk. So this is what happened. And later, in end of August, we saw that Rapid7, they blocked about the same TTP, whatever we saw in our environment. So they blocked the same TTP. But this case, there was not only Luma stealer, there was other stealers like StealC and SecTop. Also, we could see like more info stealers like Vidar, Amade, Raccoon, they started adopting this IDAT loader technique. And more even the mature malwares like Danabot, Remcos, they also started adopting for IDAT loader technique. So this is how, like NJ said, we were like tracking from our own research as well as from the outside sources. So then we came across on Feb 2027 like, 2024, CrowdStrike, they blogged about the IDAT variant 1. So in the IDAT variant 1, it's mostly like a modular framework. So within the framework, they add like syscall-based execution and multiple injection techniques, also defense evasive logic. So these are the modules they were having. And later in July 2024, we saw that Avast published stating that IDAT loader is being used for a targeted attacks, that like they were using it for a particular targeting a particular region or a particular organization. And there comes a more important technique, which is process doppleganging, which we will see in the next slides. So process doppleganging, they were using legitimate files. The normal files like explorer.exe, msbuild.exe, but moving forward, they were using unfamiliar files like more.com, choice.com. And we also saw a major shift in TTP. Like for initial access, they were using fake human captcha. So I think you know about the fake human captcha. Like if you see a page and what they usually do to identify if we are human or not, they asked us to like copy paste a particular script. They run a PowerShell script in our system and they download the payloads. So they were started using those initial access techniques. And later we identified, like we saw across the other researcher groups where there was a IDAT variant 2. So we talked about IDAT variant 1, right? So there comes a IDAT variant 2. Here the config file was hidden inside the image pixel. So this is how they were like changing their behavior. And why this is very serious? Because they are, as we saw, it's constantly being like frequently updated, and they can be reused across multiple malware families, and even the threat actors, they are like distributing across themselves. And it's very easy to deploy because attackers no need to deploy, like develop a malware. They can just use this loader to to fetch the payload dynamically, so they can use it. And also we see a strong integration with the initial access broker, which means the access can be reused and scalable. Also, as I said, the loader is a module. So we have an opportunity to add additional codes like credential theft, or you can download multiple malwares or deploy ransomwares. So that can be done with this loader. And also they act as a packers or encryptors, so that each time when you see this loader, the version would be different. It won't be the same. Also, there is a quick adoption. So in previous slide, we saw like so many info stealers, they are using this IDAT loader technique because they are easy to deploy, they are easy to adopt. So that's being used by most of the info stealers and malwares. And also, most importantly, we don't see any ads or posts in underground forums. So it's not well known to the security groups, as we don't have any information about this IDAT loader. Since it was easy to deploy and it's been reused by multiple malware families, it got popular. And how it all started. So just I will go through the kill chain. So starting, as usual, they use the social engineering tactics. So either by a malvertising page, so victim would be like redirected to a malicious page where they would be downloading a fake Chrome browser update, or as I said, the fake human captcha. So these two methods they were following. And the file which we saw in our case was chromesetup.exe. So that file, it was having multiple components, like it had legitimate file, malicious DLLs, PNG, which is a main culprit, and random extension files. So these were the components within those files. And then the important part comes here is steganography, as you could see. So we talked about the payload was hidden inside the PNG file, right? So that they named as a steganography. So what loader does it? They check for IDAT chunk. So after the chunk, there would be a data. They extract that, they decrypt using the XOR, and they prepare for execution. So that's how they do in the first step. And later, what they do is they don't directly call the API. So usually we call the create process, such kind of APIs, right? So what they do is they follow API hashing. So at the runtime, they resolve the API like hashes into a like for example, create process, they won't call create process. Instead, they call the particular hashes. So that's how they resolve during the runtime. And how they load the malicious DLL is they follow the DLL search order hijacking. So this as well, what attackers are doing is they are placing their malicious DLL in the application directory. So if the file is getting executed, first it calls the DLL from the application directory so that it bypasses the monitoring. So they does that. And the main technique they are using here is process doppleganging. So here comes a tricky part where the malware file will be executed. For this, they are abusing NTFS transaction. So they create a file in a NTFS transaction and they write a malicious code, create a process from it, and then roll back the transaction. So while doing this, what happening is this? The process is running not on the disk but in the memory. So the file-based detection, or if we want to do any forensic analysis, we won't be able to do that because file won't be available in the system. So that's what they do by following the process doppleganging. And last, the eventscate plus direct syscall. So eventscate, what they do is like they jump from 32-bit to 64-bit because most of the EDR works in 32-bit, right? So what they do is they jump from 32 to 64 and they don't involve the APIs. As I mentioned before, they directly do the syscalls, like they use NT allocate virtual memory, NT write virtual memory. So they use that kind of direct syscall execution so that it bypasses EDR, and we find it very difficult to actually detect this loader. And
so to summarize, this is a highly modular loader, technically speaking. Like you have a lot of steps that they have executed flawlessly. We'll talk about that more. And so at a high level, if you see, these are like some of those techniques that they have used, some of those modules that have actually helped deliver the info stealer at a later stage. But you had a loader, you had an injector, you had a killer module, which is typical in any info stealer, where it targets checks for running security processes or reverse engineering tools to identify if it's a researcher's machine on which the malware is executing. If it finds any of those processes, it would just terminate itself. It wouldn't, progress further. Speaking of the DLL search order hijacking, that's kind of typical across the e-crime and APT groups. So that didn't stood out so difficult for us while analyzing, but the steganography part was very interesting because these IDAT loader campaigns would drop an archive. We'll talk about that. Inside the archive, you'll have a lot of component files, including a PNG file, as Archana was saying. The PNG file will not be dropped with .png extension. Rather, it would be of random name. So when the malware would parse through the PNG file, it would check for the PNG header. Then it will check for an IDAT marker, IDAT, and only if that is met, the next 4 bytes would be at the XOR key that it would read in the memory, and the following next chunk of code is the shell code that it gets decrypted, and then the infection continues. So Zscaler did blog about that, initially saying that these were the different malwares that they saw getting distributed through IDAT loader, or hijack loader as they called it. All right, so now let's move on to the dynamic execution part. So how would you see when it comes to execution of this IDAT loader malware campaigns? So if you run it and check it across Process Explorer, you would see parent process and child process getting launched. Typically, in a case of an info stealer campaigns, there are 2 things that you should always focus on. It could be a self-injection or a remote injection technique. The malware would not randomly target any running processes and inject its code into it. It would have been programmed to target a specific process, and if it is going to inject into that process, that's the remote code execution. And if it's going to self-inject and terminate, that's a different process altogether, and you need to investigate from those angles. Now, speaking of Heaven's Gate, this particular image, if you see, the setup.exe that you're seeing here is a 64-bit installer file, and then the moment you double-click, right, you would see a command prompt getting launched, but it's getting launched from syswow64 folder. So that's a 32-bit executable running under the context of 64-bit, and that should instantly give you a hint that am I dealing with Heaven's Gate technique, typically used for bypassing. And you can actually see here, like, if you hover the mouse on top of that to confirm that it's a 32-bit file. In an IDAT campaign, the moment this CMD gets executed, within seconds you would actually see Explorer getting launched under that as a next process. And if you're running Defender or Sentinel-1 EDRs, you would see IOA or detection alert related to process injection, and you need to be very clear about that. If the EDR or IOA is not alerting related to process doppleganging, you probably have to speak with your detection engineering team to say that it's highly likely process doppleganging, because when you see the APIs getting monitored by EDR around these events, that's a different set of API calls happening. And the API calls that happens around this execution of CMD, where there is another injection that is happening that's related to process hollowing. We'll talk about that in the coming slides. So the API calls that gets called around these events are different. For people who are not very familiar about process hollowing technique, you will have the benign process or the targeted process in a suspended state. So the process gets suspended by the malware. So when you're reverse engineering the particular stage, you would see the flag set to an argument that corresponds to the suspended flag. And then the malware would write the code onto the area that it decides to write. After nullifying or zeroing out that particular block, the malicious code gets added there and it would be resumed as a thread. So we'll talk about those API functions in the coming slides. So that's one way of process injection happening here, and the process injection that happens into Explorer.exe is a different one, process doppelganging. So the API names would be different. As she said, it happens in a transactional style. And that's to protect the data integrity. So that's an additional check that attackers have performed and invested their time to ensure that post injection of its code into the benign process, the parent process doesn't get corrupted and ends there. They have successfully made it run flawlessly, so that post execution or injection the code into Explorer.exe, the info stealer code starts executing. Now, there's a lot of step-by-step diagram, by the way, but so you have the infection starts from the download of an MSI file, typically from an infected web page. Now, when we started studying this campaign at the start, I think around May of 2023, initially there was some kind of similarity to Sogolish malware campaigns, because Sogolish is a malicious JavaScript file. I think it's tied to Clop ransomware group. And this particular infection was first studied when Sogolish group targeted Garmin in 2019, if I'm right. So the infection looked kind of same to Sogolish infection pattern, where you have a compromised website that leads to download of net support rat and so on. But in this case, it was an MSI file that got downloaded. The MSI file, once it's being executed, a lot of component files are dropped into a particular directory. You would see DLL sideloading happening. That malicious DLL is the first stage where the decryptor starts functioning. So you would see an attempt to bypass EDR through unhooking NTLL hook. There were two variants that we studied. The first variant is where we have seen the malware actually downloading a PNG file from a C2 domain. We'll show the reverse engineering code of that. And the second variant is where we have seen the PNG file getting extracted from the resource section of the binary, or it gets just dropped into the same directory, just like that. These were like the key differentiating factors of the two variants. And then you would see a lot of XOR decryption happening at multi-stages, because the shellcode gets written in different regions, one after another, by the decryptor getting executed from the DLL file. While reverse engineering, you would also see that there's a step called DLL stomping, which is like only the text region of a DLL gets modified, and this encrypted data gets written to that text section of the file and gets decrypted for the successive stages of kill chain. You can just imagine, like, all this has been happening flawlessly. That's a great job by the threat actors. What made it even difficult for us to stay ahead of this particular IDAT campaign is that we had this point in the previous slide. We never saw an advertisement in the underground forum claiming like, hey, there is a new loader out there that's able to do these 10 steps, which are done by IDAT loader as such, because we could have got a detection strategy planned. Now, DLL stomping was done, and then comes even more difficult part. You had an injector module and a loader module. Soon after this DLL stomping happens, both injector and the loader module would perform the exact same steps. Both would perform Heaven's Gate. They would start creating random folders and random text names, leveraging or calculating the environment variable and few other seeds like the timestamp and random number generation. They would create random file names and folders. And then, the injector module would inject the code into cmd.exe, the one that we saw in the process kill chain in the previous slide. The loader would do kind of very similar part using the file that was dropped in the previous stage here. Under injector, this file gets utilized under the loader module, and it is from that file that explorer gets injected through process doppleganging, leading to an infostealer launch. All this were happening flawlessly. I keep reiterating that because that's a phenomenal work by the threat actor group. We have never seen the malware file getting crashed. Over 100 plus incidents that we have investigated in the 18 months time. Now, let's break down. So, the decryptor module, we'll talk about that. So, throughout the execution of all the steps, right, malware authors have called this NT delay execution function or API function intentionally to slow down the execution. That's a careful step that they have taken, which is great, because they didn't want to rush and launch the infostealer at one go after all those steps. Now, they did perform a constant check about presence of any of these researcher tools like ProcessMon, ProcMon, IDA, OLEDBG, Immunity Debugger, and so on, just to confirm that the malware is not running inside a researcher's machine. That particular image is from Zscaler, thanks, but this is from our analysis. You would actually see the strings when you decrypt multiple times and land up in a memory region, and then you check from the dump, you would see the strings. API hashing, a lot of malwares do, ransomwares also use API hashing. That's just to not let API function names be on a visible string format when you do a static analysis, just to evade detection. So typically you would see API hashes related to functions from ntdll, kernel 32dll, and wininet.dll in IDAT loaders getting hashed. So while you debug, you would be able to find the actual API names associated with these DLL names. This is a code from, I think, Vidar infostealer, one of those infostealers that used IDAT loader, where after hashing, you would see the necessary API functions being retrieved before the outbound internet connection check is being performed. So it first checks for the presence of internet on your machine and then continues. That code was from, I think, X32 debugger, and then you use a disassembler like IDA and you'll be able to do your analysis, just rename based on your analysis, and you'll be able to see, the API or the function that is responsible for API hashing and the API names that you would be able to resolve as you follow down the steps. This code here, it gives you a hint of when the DLL stomping starts. You can see that the malware would make a copy of mshtml.dll from syswow folder. From the dump, you will also get the string related to cmd.exe. And that's the exact starting stage when the Heaven's Gate step would be performed at next stage. There is a decryption loop, and then the shellcode gets decrypted using this RTL decompressed buffer. So that image that you see there was related to Heaven's Gate, and this is the code that you would actually see. So you want, like in a 64-bit machine, you want a 32-bit to get run, you would actually see this kind of code there, like 33 or 23 as reserve byte. I don't exactly remember the name, it's called reserved selector or so. So you want another process to run in a different operating system model. This really helps. Post this is when you'll have the direct syscall executed by the malware to evade EDR solutions. So for people who don't know, like, so you have the user mode, you have the kernel mode. For any application that needs this API to be called, it goes through user mode all the way to NTOS kernel, fetches the equivalent and goes back. So so the EDRs typically, for some of those EDRs perform inline hooking, which means it modifies the first 5 bytes of the prologue with a jump instruction, goes to the proxy function or the trampoline function of EDR. Once EDR scans through the arguments of the function, it jumps back to the very next address where this jump instruction is performed and the code flows. So what the malware does is performs a direct syscall all the way, thereby it's able to bypass some of those EDR solutions. Let's move on to the injector module. Injector module was the one that was responsible for injecting its code into cmd.exe through process hollowing. And here are the list of API functions that was responsible for injecting the code post suspending the victim processes. So from a SOC analyst or reverse engineering angle, the SOC analyst would typically triage the event when there's an alert, right? What we were seeing was the EDRs were missing and the SOC analysts were on a blind spot. So with our threat hunting query, they were able to execute in their environment and they were able to spot it. That's when we educated the SOC analyst saying that go beyond the EDR alerts, look for these kind of traces or events, study the process kill chain tree, check for injection techniques, and if you are dealing with a target process like cmd.exe or in the next stage like explorer.exe, making an outbound connection to a suspicious TLDs associated with an info stealer, you can be very sure that you are dealing with IDAT loader or any other info stealer. We'll talk about that. Let's move on to the loader module now. So you had the injector module. I told you that, calculating the environment variable and a lot of values from random seeds and timestamps, it was able to create random file names and random folder names. So the file would be taken by the loader at this stage, and then it starts performing the process doppleganging to inject its code into explorer.exe. Now, again, like the previous slide, as a threat hunter or investigator, look for the API calls that it's going to deal with. These were those different API calls that you would deal with when it's process doppleganging. You would see API calls related to the NTFS transaction model, which is related to process doppleganging. So some of this, quick tip, some of these API functions would have transaction. This is to protect the data integrity. Either you commit and write into the benign process or just roll back. That is the plain message of process doppleganging. So there won't be any error of corrupting the files. That's what you are seeing here. And then the final payload gets executed through explorer.exe. Speaking of those two variants, the first variant is where we said that, it's going to download the PNG file from the internet. So before that, it would load WinSTTPL and MSVCRT into the memory. And then it makes fake requests to the legit domains where the PNG files are hosted, downloads it, starts loading it in the memory, checks for the IDAT string, reads the key, and starts decrypting the shellcode from the next level. This is that code that's responsible. So a request is being made. You would see some URLs. You can see it's ending with .png file. It also checks for the presence of internet. An example of the PNG file that was having the shellcode, steganography technique. So that was one of those images. You could see the blur image. Typically, that's where the shellcode resided. The code on the left side, you can see there's a PNG header at the start. And after a few bytes, you see the IDAT marker. So the malware actually reads through the PNG file, checks for that marker. The next 4 bytes is the key. Following that is the shellcode that it decrypts in memory. So nothing gets executed at the disk level. That's the loop that you're seeing there where it starts decrypting the code. In the dump, you can see the PNG file in memory being loaded. And once it starts decrypting, you move to the next stage. This is just another view, giving you the dump view, how it looked in the debugger. In the second variant is what I was saying, like either the PNG file gets extracted from the resource section of the file or gets dropped along with the other component files in the same directory. Now the PNG file need not be with .png extension. It can be any random thing, and that's what we are seeing. All the files are with random extension except the legitimate exe that loads the malicious DLL through side loading at the initial stage. Rest everything was happening flawlessly. So the .r file that you see there is the actual PNG file in variant 2. And for the variant where the PNG file was getting extracted from the .r data session of the file, this is that code, and that's the decryption function that starts post extracting the code from the R data section of the binary. With all that, this was very critical for us. So you had variant 1, variant 2, some level of the code really matched. Some of those info stealers that used variant 1 at the time of our study was Amade and Raccoon. Variant 2 was seen used by Luma and Vidar. This helped us to understand, at least during a small time frame, we were able to see that the same level of code was used by attackers across different info stealers, and that gave us a fair understanding that there is some group out there sharing the code among themselves to launch different attacks against global organization. Not a big deal for us, but from a customer's standpoint, they have invested a lot of money for EDR solutions or other security solutions. We had to educate them to understand like what are they dealing with, what are we seeing, and who are their enemies. Here's those 4 hashes that we reverse engineer. Samples are there in VirusTotal. They were not taken from incidents. So, reiterating the other point, when the main installers were seen at the initial times, right, initial days, they were using all these different random names, WebEx, Defender, OneDrive, Blu-ray setup, AnyDesk, all that. And users were actually tricked to either download, some random binaries from different websites that impersonated legit pages. The best part was like the attackers kept changing the benign process that they initially started targeting to inject. Initially it was CMD, then they moved into different processes over the months. Back to the summarization slide. So what we started seeing from 23rd of August, around the same time when Rapid7 also studied about IDAT loader, we continue to see different info stealers adopting this IDAT loader, and CrowdStrike blogged about it. Avast also blogged about it. And then around July or August, close to about after a year is when they started changing their targeted process, which was very interesting. For no reason, we are really not sure why it took so much time for them to just change the victim process name into their code. But it was good. But it is only after that the fake CAPTCHA campaigns started rising around the globe. But still we saw, info stealers getting dropped. We're having some kind of similarity or tie-ups to the IDAT loader around December or February 2025. So it has been there. And after that time frame, you still have all these fake CAPTCHA campaigns running around. But we are not actually seeing IDAT loader campaigns in the recent months for sure. But throughout this year, it was a great time for us to study all those similarities that we highlighted. John from Hunters was also talking about this in his YouTube video where he spoke about more.com. I think he missed to speak about more.com, but from the any.run sandbox that was highlighted. So we are in line with the security community with whatever they are working on, trying to protect the world. From a threat hunter's side, I'll just try to reiterate this. Look into injection-related TTPs. It could be a pen testing happening or it's an info stealer happening. Either ways, it's always worth to let your customers know what they are dealing with. Check for gaps of your EDRs. Partner along with your detection engineering team to understand how you can fix that. Work with the SOC team so that you can help them cover up the blind spot. Hunt for any additional IOCs, TTPs, working closely with the threat hunting team. I told you about the info stealer that's getting launched post-injection into explorer.exe, right? there was an easy takeaway. All those domains that InfoSealers were connecting or making outbound connections, right? They were pretty tricky, and it was very easy to spot. You had like .shop, .cyu, some random or .space, something like that getting launched from Explorer.exe's context, which is not the right thing. So it was an easy takeaway for us. So if you simply create a hunting query to look for outbound connections to such suspicious TLDs, and if there is a hit, backtrack. And when you backtrack, if the source process is a browser, I don't know what to call that, it's okay. But it's not okay. I would say that there's an InfoStealer in your environment, but if the spawner process is an exe file and then you see injection and all that, you can be very sure that you're dealing with an InfoStealer infection in the environment. And then if you see some random files getting created into temp folder, app data folder along this timeline, you're dealing with an InfoStealer incident for sure. With that, thank you so much. Thank you, B-Sides, for having us here. If you have any questions, we'll be more than happy to answer.